Lesson 34, Hypothesis Testing Procedure for One Population Proportion. So we have an idea what the value of a particular population parameter is. We could test the validity of that idea using hypothesis testing procedures. And if the idea involves just one population proportion, these are the steps we can follow to guide us through the hypothesis testing procedure. Now, hypothesis testing procedures begin with the formation of a hypothesis. The stated hypothesis must be expressed in a form that can be tested statistically. To do this, we select the paired forms of HO and H1 that correspond to the stated hypotheses. There are three pairs: HO, H1, involving the P equals a particular value versus P not equal to a particular value, or the HO, H1 of P greater than or equal to a particular value, or P less than a particular value, or the HO, H1 of P less than or equal to the particular value, or P greater than that particular value. Once the selected pair forms of HO and H1 that correspond to the stated hypothesis is made, then we can go on to the next step. Unless there exists a compelling reason to do so otherwise, hypothesis testing procedures are conducted using the customary 5% level of significance, or alpha equal 0.05 decimal. Now, after the random sample has been collected, and the sample result, x, and the sample size, n, have been determined, the oneprop-z-test command on the TI-84 calculator will calculate the desired p-value for the hypothesis test procedure. It's this p-value that will be used to help reach our decision. On the TI-84 calculator, the oneprop-z-test command is found by pressing stat, arrow over to tests, and then arrow down till the cursor gets next to oneprop-z-test, and then press enter. P sub 0 is the actual number that shows up in the hypothesis. X is the particular data value corresponding to this sample. N is the total sample size for the sample. H1 is either a not equal, a less than, or greater than inequality. We just arrow over to the one that matches the one in our test, press enter to select, and then down arrow to calculate. Pressing enter will calculate the p-value, in addition to other results. But the one that says P equals is the p-value that we're going to use to reach our decision. Not to be confused with the p hat, which is the sample proportion. The formula that's programmed into the oneprop-z-test command is the standard score, and the standard score for the sample proportion is used as the test statistic for this hypothesis testing procedure. The corresponding p-value is calculated using the results of the central limit theorem. Therefore, in order for the normal approximation to be reasonable, the sample size must be sufficiently large, for our purposes n greater than 30. With sample proportions, smaller sample sizes do not produce reasonable approximations. Therefore, we never conduct proportion problems with insufficiently large sample sizes. Now, the calculated p-value is used to reach a decision regarding the validity of the form of the hypothesis indicated in HO. Small p-values provide sample evidence contradicting HO. Large p-values provide sample evidence consistent with HO. So the decision is to reject HO when the p-value is less than or equal to alpha. When HO is rejected, the form of the hypothesis expressed in HO is considered invalid. Consequently, the form of the hypothesis expressed in H1, which is the opposite of HO, is considered valid. When HO is not rejected, that is, when the p-value is not less than or equal to alpha, the form of the hypothesis expressed in HO cannot be dismissed. Now, careful consideration must be given when interpreting this decision. That's because either HO cannot be rejected because HO is indeed valid. Therefore, we do not reject our valid ideas. Or because there is not enough sample evidence to clearly indicate that HO is indeed invalid. That is, it may be the case that HO is not valid. We just don't have sufficient sample evidence to indicate this beyond a reasonable doubt. Finally, based on the interpretation of the decision reached in this hypothesis testing procedure, that is, whether we reject the HO or do not reject the HO, an appropriate conclusion can be stated in terms of the issue under investigation. That is, we need to, in words of the problem, state our conclusion addressing the original hypothesis. So the following examples will help demonstrate how a hypothesis test procedure is used for one population proportion.